Hi everyone, this is Arvind from MindMajix, and today I welcome you all to this amazing session on manual testing interview questions. So, guys, in this particular video, we will be covering roughly 30 questions, and these 30 questions have been divided into three categories. The first set of questions, like the first 10 questions, are meant for the beginners or the fresher people. After that, the next 10 questions will be for the experienced people, like those people who have at least 2 to 3 years of experience in manual testing. And finally, the third set of questions is for the advanced people, like those people who have at least 4 to 5 years of experience in manual testing. So, guys, this is the whole agenda for today's video. And before moving ahead, I want you guys to subscribe to MindMajix YouTube channel and also hit that bell icon so that you never miss an update from us. So, without any further delay, let's get started with our first question. So the first question over here is a very basic question, and it is pretty much obvious that you will be asked the definition of manual software testing. So the question says, what is manual software testing? So guys, before even answering what is manual software testing, let's just understand what is software testing in general. So software testing is the process of checking whether a software application works as expected. So this helps us find bugs, errors, or any other missing features to ensure that the software runs smoothly. The main idea or the main goal of testing is to make sure that the application meets the required specifications, it functions correctly, and performs well. So in simple words, it verifies whether the software is reliable, user-friendly, and ready to use. And now if you talk about manual testing, so manual testing is a type of software testing process where the test cases are executed manually without any use of automated tools. So what happens over here is the tester verifies that the software functionality in a manual way. After that, the tester has a list of all the test cases that need to be manually tested. They go through each test case and they verify the output. So it is inefficient in comparison to automated testing, and it is slow as well, and it does not repeat in a consistent manner. So the final conclusion of manual software testing over here is that manual testing is prone to human misjudgment. So this was a quick overview of what exactly is manual software testing. Now let's move ahead and discuss the next question. So the next question says, why is testing required? So guys, in this particular question, you need to answer this by giving the reasons why software testing is required. So the first reason over here is that testing provides an assurance to the stakeholders that the product works as intended. The next reason is, by doing software testing, you can avoid defects to the end customers without proper testing, and this can add a bad reputation to the development company as well. So if at all without any testing you give the product to the end user or the stakeholders, and if at all they discover any problems or errors in the application, then your company's reputation is at stake. The next reason is that since defects are detected earlier in the software development lifecycle, this can result in lesser cost and less utilization of resources for the correction of the software or the application. The next reason could be software testing saves development time by detecting issues earlier in the phase of development itself. And last but not the least, the testing team adds another dimension to the software development by providing a different viewpoint to the product development process. So these were some of the reasons which explains us that why is testing required. The next question is, explain the software testing life cycle. So the software testing life cycle refers to all of the activities that are performed during the testing of a software product. So the software testing life cycle includes various phases, as you can see on the screen. These are the various phases like requirement analysis and validation. Then you have test planning. Then comes test design and analysis. Next, you have test environment setup. After that, the test execution. And last but not the least, test closure and reporting. So if you talk about requirement analysis and validation, so over here, the requirements documents are analyzed and validated, and the scope of testing is defined. Next comes the test planning phase, wherein the test plan strategy is defined and the estimation of test effort is defined along with automation strategy and the tool selection as well. Next comes the test design and analysis phase. Over here, the test cases are designed, test data is prepared, and the automation scripts are implemented. If you talk about test environment setup, so a test environment closely simulates the real world environment, and over here your product is tested for real life scenarios. Next comes the test execution phase. Over here the test cases are prepared, bugs are reported, and the retested ones are resolved. And last but not the least, if you talk about test closure and reporting, so a test closure report is prepared to have final test results in a summary, learning, and test metrics. The next question is, what exactly is the difference or the distinction between verification and validation? So if you talk about verification, so in verification, you evaluate the various artifacts and the process of software development. This is done in order to ensure that the developed product meets the required standards. So this is a static process of document analysis rather than the actual end product. If you talk about verification, so this is pretty much a systematic approach. So the main question that is answered by the process of verification is that, are we building the product correctly? And in verification, what happens is errors are discovered during the verification, require less cost or resources to fix than the errors found during validation. And now if you talk about validation, so validation is the process of ensuring that the software product developed meets the specified business requirements. So it entails running a software product to perform dynamic testing. So in short, validation is a product focused strategy. And the most important question that is answered in validation is that, are we making the right product? So the errors discovered during validation necessitate additional costs and resources. So when an error is discovered later, the cost of repairing it increases. I hope this clearly explains the distinction between verification and validation. So now let's move to the next question, which is, what is quality control and how does it differ from quality assurance? So basically over here, the interviewer is trying to understand what is the difference between quality control and quality assurance. So if you talk about quality control, basically the quality control process focuses on identifying the defects and errors in the final product or services. Whereas if you talk about quality assurance, so this phase focuses on preventing the defects and errors from occurring in the first place. So even before the actual product is developed or in the development phase, like during the entire development process, quality assurance focuses on preventing the defects and errors. The next point is, if you talk about quality control, so quality control is performed after production to ensure that the final product meets the specific or the specified quality standards. Whereas if you talk about quality assurance, so this is performed throughout the production process in order to ensure that the quality standards are met at every stage. The last and the most important point over here is, if you talk about quality control, so here inspecting and testing the final product or service to meet the specific requirements is done. Whereas if you talk about quality assurance, so this involves planning, designing, and implementing quality management systems in order to ensure that the products or the services consistently meet customer expectations. So over here in quality assurance, at every phase, you are checking or verifying the quality of your product. And if there is something wrong or if something goes against the requirements of the customer or the stakeholders, then you take the feedback and you make the necessary changes. So this is how you improve the quality at every step. I hope this clearly explains the difference between quality control and quality assurance. The next question is, what are the different levels of manual testing? So there are basically 4 levels of manual testing, as you can see on the screen: unit testing, integration testing, system testing, and user acceptance testing. So let's discuss them one by one. So if you talk about unit testing, so this is a way of testing the smallest piece of code, and this is referred to as unit, and that can be logically isolated in a system. So it is mainly focused on the functional correctness of the standalone module. Next comes the integration testing. So this is a level of software testing where individual units are combined and tested to verify whether they are working as they are intended to when they are integrated. The main goal over here is to test the interface between the modules. Next comes the system testing. So in system testing, all of the software components are tested as a whole to ensure that the overall product meets the specified requirements. So there are dozens of system testing processes, which includes usability testing, regression testing, and functional testing. And finally, we have the user acceptance testing. So the final level, the acceptance testing or the user acceptance testing, determines whether or not the software is ready to be released. The next question is, what is a test bed in manual testing? The test bed is an environment configured for testing. So it is used to test an application, including the hardware and any software that is needed to run the program to be tested. So the test bed consists of the hardware, software, network configuration, and application under test and other related software. The next question is, what is a test scenario? So a test scenario in software testing is a detailed description of a specific functionality to be tested. So basically, it outlines the conditions, the inputs, and the expected outcomes for testers to follow. So by replicating the real world interactions, test scenarios help us uncover defects and ensure that the software meets the specified requirements. Basically, test scenarios aid in identifying the issues early, and this allows us for timely resolution even before the release, and this contributes to a reliable software product. The next question is, what is SDLC or software development lifecycle? So basically, software development lifecycle is a methodology followed within the software organization to build the high quality software at low cost. So it does the planning of what the software has to perform, then design how it will work, and then create it. After that, there are tests executed on the software to ensure that everything is in place. Once everything falls in place, the system is ready to be deployed for people to use. So even after the release, a developer continues maintenance or an update of this software in order to run it smoothly and further develop the features of the application. It may turn out in a properly structured process, one seeing reliability and consistency in serving the user interests regarding the software. The next question is, what is a test script? So test script is a set of instructions or the lines of code written to automate the execution of the test cases during the software testing process. Basically, it outlines the sequence of actions that need to be performed by the testing tool or the framework to simulate user interactions with the software. So test scripts specify inputs, expected outcomes or the outputs, and validation criteria at each step, and this allows for repeatable and consistent testing. So test scripts are particularly valuable for regression testing, where repetitive tests need to be executed in order to ensure that new changes haven't introduced any defects. So guys, with this, we have covered the beginner level questions related to manual testing. And now question number 11 to 20, we will be covering the intermediate questions. So the next question over here is, explain requirement traceability matrix or RTM. So the RTM or the requirements traceability matrix is defined as a tool that is used to identify and track the requirements and deliverables of a project. So this is accomplished by establishing a thread for each component. Apart from this, it manages the overall requirements of the project. So there is nothing complicated about this method and it can be done by anyone. RTMs come in many forms. So test matrix, for example, proves that the tests were conducted. Additionally, it can be used during the software development process to identify the issues and the requirements. The next question is, what is a pesticide paradox and what you can do to overcome it? So the pesticide paradox is basically a phenomenon where more than one test are done on the software and the more it becomes immune to the tests. So to overcome this, the testers should always find new strategies, approaches, and test cases so that they can identify bugs and resolve them. So if you talk about preventing the pesticide paradox, there are a few steps that you can perform. So first step is create a new set of test cases for different components of the software. Apart from this, you can add new test cases to the existing test cases. And the use of these methods can lead to finding more defects in the areas where defect levels have declined. The next question is, how do you know that the code has met the required specifications? So code that is maintainable, readable, and bug-free is considered as good. So almost every organization has coding standards that the developers should adhere to, but everyone has a different ideas about what's best and what's good and what's bad. So many tools are available in order to ensure that the test cases are mapped to the requirements, such as traceability matrices. So in the event all test cases are successfully executed, then the code fulfills the requirement. The next question is, what are some of the best practices that you should follow when writing test cases? So guys, there are a few best practices that you must follow when writing the test cases. And those best practices are, as you can see on the screen. Let's discuss them one by one. So the first point over here is prioritizing the test cases. So you must prioritize which test cases to build based on the application's risk considerations and the project timeframes. The second point over here is following the 80-20 rule. So to ensure the sufficient coverage, it is better to have 20% of the test cases covering 80% of the application. The next point is categorizing the test cases. So over here, you have to list all of the test cases and categorize these test cases according to the business scenarios and functionality. The next point is designing modular test cases. So you have to make sure that the test cases are modular and as detailed as possible. And last but not the least, you have to remove the duplicate test cases. So as a software tester, it is your job to remove the irrelevant and duplicate test cases. The next question is, what is the role of documentation in manual testing? So documentation plays a vital role in manual testing. So it is important to document all of the steps taken in testing process in order to ensure that sufficient test coverage and accurate results are established. So it provides an audit trail which can be used to evaluate past test results and identify areas of improvement. So it also serves as a reference for other testers who may be unfamiliar with the system. The next question is, what is defect cascading? So defect cascading in software testing means that when one defect leads to the discovery of other defects. So it often occurs because the original defect was not fixed properly. So this cascading causes a chain of reactions of errors, and this makes it very difficult to source the problem. So defect cascading can lead to many issues like minor performance slowdowns, system crashes, making it a severe risk to developers and testers. So understanding defect cascading can help us prevent from happening in the first place in the development process. The next question is, when to use manual testing over automation testing? So there are many scenarios where manual testing can be opted over automation testing in a software project. And those scenarios are, as you can see on the screen, ad hoc testing, exploratory test, usability testing, and short lifecycle projects. So if you talk about ad hoc testing, so ad hoc testing can be achieved using manual testing as there is no specific approach, and this is performed without planning and documentation. So in ad hoc testing, the understanding and insight of the tester plays a very important role. The next scenario is exploratory testing. So exploratory testing depends on the tester's knowledge, experience, and logical skills. So human involvement is a must here, and manual testing is the best choice for exploratory test. Next comes the usability testing. So in usability testing, human observation plays a very important role as it is measured by the tester how user-friendly and efficient the software is for the end users. So manual testing is an appropriate choice for usability testing. And last but not the least, short lifecycle projects. So automation testing is not appropriate for short-term projects as it requires high investment and planning, and manual testing, on the other hand, aims to save time and resources. The next question is, explain boundary value analysis in software testing. So boundary value analysis is a black box software testing technique that uses boundary values to create the test cases. So input values near the boundaries have a higher probability of error. So boundary value analysis is used to test the boundary values. Boundary value analysis, or BVA, includes values at the boundaries in the test cases. So if the input fails within the boundary range, then the test is positive. If it fails outside, then it is negative. So there are several types of values, including maximum or minimum, inside edge or outside edge, typical or error values. The next question is, what is cross-browser testing? So all web applications run in web browsers such as Google Chrome, Mozilla Firefox, and Internet Explorer. So though they all work primarily in the same way by implementing the web standards, so there are certain differences in all of them. So when building the software, it is not always possible for the software developer to meticulously test the feature on multiple browsers, noticing the subtle inconsistencies. The next question is, let's suppose there is a scenario. So in this particular scenario, a defect that could have been removed during the initial stages is later removed. So what effect does this have on the cost? So if a defect is discovered during the project's initial phase, it is important that the defect is removed during that phase rather than later during the development process. So the cost of fixing a defect increases greatly if it is delayed until a later stage in the development lifecycle. So it is a more cost-effective option to eliminate defects during the design phase, but it becomes 20 times more expensive to do so in the maintenance phase. So in simple words, the later you remove the errors in the development process, the higher your cost would go on the application. So guys, with this, we have covered the intermediate level of questions for manual testing. And now question number 21 to 30, we will be covering advanced questions related to manual testing. So the next question is, what is equivalence class partitioning? So equivalence class partitioning is a software testing technique that involves dividing the input domain of a software component into groups or partitions that should exhibit similar behavior. So this technique helps us reduce the number of test cases required to test the software by selecting one test case from each partition to represent the behavior of all other test cases in the same partition. So by using the equivalence class partitioning, defects in the software can be identified and the quality of testing process can be improved. So this technique is commonly used in black box testing to improve the efficiency and effectiveness. The next question is, if the specifications haven't frozen, how can you test a product? So the optimal strategy over here is to employ an agile development technique such as Scrum when requirements have not yet been frozen. So the very first step is to comprehend the goal of the product and the intended outcomes. So the project would then be divided into small, manageable user stories as the next phase. After that, one could rank the user stories and assign them to a development sprint. So by using the methods like unit tests, integration tests, and user acceptance tests and system testing, we continuously test the product as project advances. To guarantee the solution achieves the desired results, we will also update our test when the needs change. The next question is, what do you mean by configuration management? So system's integrity may be preserved, and configuration management can make sure that a system is safe, reliable, and compliant with organizational policies. So it involves managing, monitoring, and regulating adjustments made to the network configuration, hardware, or software of a system. So assuring system dependability, maintaining system availability, and enhancing system performance are the core objectives of configuration management. The next question is, what is the difference between bug leakage and bug release? So bug leakage is when the tested software is released into the market and end user finds bugs in it. So these include the bugs that got missed by the testing team during the testing phase. Whereas if you talk about bug release, so this is when a specific version of the software is released in the market with some known bugs which are intended to get fixed in the later versions. So these types of issues are of low priority and are mentioned in the release notes while sharing with the end users. The next question is, what is cyclomatic complexity? So cyclomatic complexity is the measure of the number of independent paths in an application or a program. So this metric provides an indication of the amount of effort required to test complete functionality of the application. So the best way to define the cyclomatic complexity is by the expression L minus n plus 2p, where L is the number of edges in the graph, n is the number of nodes, and p is the number of disconnected parts. The next question is, what are the different roles in Scrum? So the different roles in Scrum are, as you can see on the screen, product owner, Scrum master, and Scrum team. If you talk about product owner, so he's the one who owns the whole development of the product, assigns the tasks to the team, and acts as an interface between the Scrum team and the stakeholders. If you talk about Scrum master, so the Scrum master is a person who monitors that the Scrum rules are followed in the team, and the Scrum master conducts Scrum meetings as well. So basically what happens in Scrum meetings is, daily you discuss what are the tasks that you're working on, what is the previous work that you have completed, and in the current tasks that you are doing, are you facing any blockers or not? So this is discussed in the Scrum meeting, which happens daily. And the third role in Scrum is the Scrum team. So a Scrum team participates in Scrum meetings and performs the assigned tasks. The next question is, what would you do if you find a high severity bug just before the release? So there are a few ways through which you can handle a high severity bug just before the release. So the first way could be reporting the issue immediately to the stakeholders with all of the relevant details. Since over here you do not have the time to hold back the application, so it is best to inform the stakeholders that so and so issue can be seen in the application and provide the details as well. The next approach could be collaborating with the development team to assess the impact and find a quick resolution. So whenever such thing happens, what you can do as a tester is get in touch with the development team and try to identify what impact it is going to have on the application. So depending upon the impact, so let's say if the impact is too much or it is going to affect the application in a very bad way, so try to find a quick resolution or a quick solution in order to resolve that bug if possible. Another approach could be testing the fix thoroughly to ensure that no additional issues are introduced. Apart from this, what you can also do is, if the bug cannot be fixed in time, so discuss possible workarounds or delay the release. And the last approach could be updating the risk assessment and documentation for future releases. The next question is, how do you handle a situation where a defect cannot be reproduced? So again, in this particular scenarios, there are a few steps or approaches that you can follow, such as collecting as much of information as possible, such as logs, screenshots, or steps from the reporter. Next, comparing the test environment and production environment for any discrepancies. So let's say the test environment and production environment are not matching for any given reasons. So you have to compare that and you have to note down the differences and how you are going to resolve those differences. Another approach could be collaborating with developers and other team members to analyze the issue and using exploratory testing techniques to identify the edge cases or timing issues. And last but not the least, documenting all of the findings and updating test cases accordingly. The next question is, how are you going to handle a severely buggy program? So when dealing with a severely buggy program, a systematic approach is essential to identify, prioritize, and resolve the issues effectively. So there are a few steps or approaches that you can utilize when you are facing such a situation. So the first approach could be bug triage. So start by categorizing and prioritizing the bugs based on the severity and impact on the program's functionality. So over here, critical bugs affecting the core functionalities should be addressed first. Next comes the isolate and reproduce approach. So over here, you reproduce the bugs in a controlled environment to understand their triggers and conditions. So isolating the bugs helps us in diagnosing the root causes. And once you identify the root causes, So the next approach could be isolate and reproduce. So over here, you reproduce the bugs in a controlled environment in order to understand their triggers and conditions. So basically, isolating the bugs helps us in diagnose the root causes. The next approach could be root cause analysis. Over here, you conduct a thorough investigation to identify the root causes of the bugs. So this may involve reviewing the code, logs, and system behavior to pinpoint the areas that require correction. Another step could be fixing the bugs. So over here, you develop the patches or fixes to address the identified issues. So once the issues have been identified, you have to implement solutions that not only resolve the immediate problems, but also consider the potential implications on other parts of the program. And last but not the least, what you can do is you can perform unit testing. So over here, you roughly test the individual fixes through unit testing in order to ensure that they don't introduce new problems or regressions. The next question is, can automation testing replace manual testing? So automation testing isn't a replacement for manual testing. So no matter how good automated tests are, you cannot automate everything. So manual tests play an important role in software development and come in handy whenever you have a case where you cannot use automation. So automated and manual testing each have their own strengths and weaknesses. Manual testing helps us identify the entire problem and more flexibly explore other angles of the tests. On the other hand, automated testing helps us save time in the long run by accomplishing a large number of surface level tests in a short time. So guys, with this, we have come to the end of this session on manual testing interview questions. I hope you guys have enjoyed this session. If at all you have any doubts or queries related to the questions that we have discussed here, you can write your queries in the comment section and we will try to resolve your queries as soon as possible. So guys, thank you so much for being with us and I wish you all the very best for your upcoming interview.